Okay, so moving on. A company operates trains. The company claims that 92% of its trains arrive on time. You should assume that in a random sample of trains, they arrive on time independently of each other. Assuming that 92% of the company's trains arrive on time, find the probability that in a random sample of 30 trains operated by this company, exactly 28 arrive on time or more than 27 arrive on time. Okay, by now we should be getting excited because we've heard and seen all of the clues that we're going to be working with a binomial. Firstly, we were given a probability of a train arriving on time. That's the probability of success. We were told that they were independent, so that's just consolidating that it fits the criteria for binomial distribution. And here we were given a value of n. Okay, let's set out this distribution. So from here, I can tell that x is going to follow binomial of 30 and 0.92. Okay, so this one is not in the tables. This is definitely one for your calculators. And we want to find the probability of exactly 28 trains. Okay, before I do that, I'll just get the expectation. I can't help it. I'm in a habit. I always find the expectation. So 27.6 trains should arrive on time. All right, so A, probability that x equals 28. So an exact probability. You can type that into your calculator using BPD, or we can work it out the long way around. So this is basically what we're going to substitute into, where n is 30, n is 30, p is 0.92. So substituting that all in, I'm going to get 30c 28, 0.92 to the power of 28, and 0.08 to the power of 2. And that gives an answer of 0.2696. Using your graphics calculator, we could have typed this in. We would have had to go to options, then probabilities, then the binomial distribution, and we would have used the BPD, substituting in 28, followed by n, followed by RP. Okay, and that would have got you the answer in one step, but obviously you need to know how to use your calculator extremely well to be able to use that as an assistance. Okay, so moving on. The journalist believes that the percentage of trains operated by this company which will arrive on time is lower than 92%. To investigate the journalist's belief, a hypothesis test will be carried out at the 1% significance level. A random sample of 18 trains is selected. For this hypothesis, state the hypotheses and find the critical region. All right, as always, clues in the question. Where are they? This journalist believes that the time is lower than 92%. That's going to give me my alternate hypothesis. We're going to be using a 1% significance level, and I've been told that there's a sample of 18. Be really careful here. We will ask for critical region rather than any other sort of hypothesis test. I can anticipate some people would use an n value of 30 and an observed value of 18. So be really careful what these values represent. Let's get to it. So the null hypothesis is that the situation is as normal, the situation is as advertised, and that the probability that a train is going to arrive on time is 0.92. The journalist, however, does not believe this and says that the probability a train arrives on time is less than 0.92. Just for future reference, let's just say that this is the journalist's claim. All right, so if we were following this distribution, x would follow a binomial of 18, 0.92, with an expectation of 16.56. Okay, let's say exactly what P is used for. Don't forget this is usually worth a mark, defining exactly what P is. And it is, in this case, the probability that a train arrives on time. Okay, so to carry out this hypothesis test, we need to set out the critical region. What exactly is the critical region? One of these diagrams usually helps to clarify exactly what's going on. Firstly, my alternate hypothesis is that we're looking for the probability to be less than 0.92, meaning I would expect fewer than 16.56 trains to be on time. So we just get in our 16.56. I want to know how few would I need to have for me to reject H0. How few trains would I need to have so that that number of trains was over here in this region where we're happy to reject, in this region which we refer to as the critical region. So we just need to do some, we just need to try some values and check until the probability that it's less than or equal to that value is smaller than 0.01. So we're looking for this situation. So in this case, find A. So really on your calculator, just going to try a few values until you locate which value this is true for. Okay, so you can check 15, less than or equal to 14, less than or equal to 13, which is where I'll jump in. And the probability that X is less than or equal to 13. The probability that X is less than or equal to 13 equals 0.0116 to 4 decimal places. This doesn't fit the criteria I was looking for. I needed it to be smaller than 1%. It's very close. So I'm quite confident that if we check 12, we'll be even closer or we'll have what we're looking for. Once again, in the calculator, 0021, there we're it. 0021, there it is. It's smaller than the 1%. 12 must be this value over here. This is my 12. Next to it, I would have had 13, but 13's not actually inside that critical region. Don't be too hasty here. So we have not quite finished. We haven't identified the critical region. We found the probability that's less than 0.01. The critical region is this value here. All right, examiners will not give you the mark if you still have that within a probability statement. Write it out on its own. Nice and conspicuous. This is the critical region. And that right there will be worth all of your marks.